driving ML engineering and operations at Volvo Cars. He is responsible for defining the overall mission and strategy for ML engineering and operations. Leading the build of reproducible ML systems, Leonard has spent most of his career as a data scientist or ML engineer. He lives in Gothenburg, Sweden with his 2 kids and lovely wife. And he's gonna present to us about the MLOps they're doing at Volvo Cars today. He's gonna get that dialogue started right now. So we've got you coming on the show, Leonard. It's great to have you here. I am excited to be talking to you, man. This is awesome. It looks like we've got a quorum started already. Leonard, welcome to the show. Hopefully, I got a little off to a little bit of a rough start there. I couldn't get the rhythm, but I don't think anybody came here for the music. They came here to listen to you talk.
Yeah, sure. Grateful to be here.
Sweet, man. I'm going to hand it over to you. And please, everyone that is with us right now, keep the comments coming, questions coming. If there's anything that you put into the chat, I'll stop Leonard at the opportune moment. He's got all kinds of really cool slides for us laid out. So I know it's going to be a pretty heavy presentation that we could take the whole hour on. We're going to try and keep that to like 30 minutes, 35 minutes, and then leave some time for Q&A, but I'll stop him at any moment if there are questions that you have. And Leonard, it's all on you. I'm excited.
Cool. Yeah, so let's just get started here. As Demetrius said, I'm driving ML engineering and operations at Volvo Cars. Just now these. All right, cool. Now it works. Sorry. So essentially, the purpose for us is to transform the company to become a machine learning powerhouse, where machine learning and AI is a major differentiator and a core component of the company's business DNA. Well, that goes for every ML practitioners at Volvo Cars, but mainly we're focusing on MLOps. And this is sort of my formulation of the objective of what MLOps is. So I won't be spending that much time on defining MLOps for you guys. I'm assuming you already know that. So let's just jump directly into sort of our approach, and we'll focus more on the sort of tooling and infrastructure side of this in the beginning. So we went with a sort of cloud native infrastructure, mainly because we already had that in place for our connected car cloud and some other clusters that host our services. So we figured using that container orchestration platform for machine learning would be kind of great. Then we wanted to glue sort of the infrastructure or whatever happens in the infrastructure with the Git flow. So we get a reflection on whatever happens in the repository, which, basically the infra. We have some templating and we try to reuse as much as possible. Yeah, and then obviously the need for sort of building an internal community within ML is quite strong. So we have a centralized knowledge platform where we host docs, guides, and information about all the projects going on at a large company. We have some software expectations from all ML practitioners, which maybe are not mega standard. They should be. And then we try to abstract ML practices into design patterns. and follow up and evangelize good principles in general. So when it comes to machine learning, we have dedicated machine learning clusters where we host like additional tooling on top of the vanilla cloud native stack, which we basically share with all of the other clusters, like Istio Service Mesh, for example, and all those basic stuff. But since the underlying sort of needs for machine learning workloads, as opposed to like hosting general web apps or other services, are quite different, we do have separate clusters for them. And we went with basically KubeFlow as a core component of that, mainly because, yeah, well, it's open source and it has a nice unified UI. And I like the way it's sort of trying to glue together multiple services, and it provides like nice abstractions towards like Argo workflows, for example, for running like pipelines and whatnot. And then some other stuff, these nice operators for like distributed training and all that. But what it was basically lacking from our opinion is the CI/CD aspect of it. So I won't be, unless anybody has any questions, I won't be spending that much time on this particular slide. We can obviously go back later on if that is the something you care about. But the CI/CD aspect is not like part of the KubeFlow offering. So we spent some time developing tasks and pipelines to sort of glue together our sort of Git repositories or projects with the KubeFlow Pipelines API, amongst other things. So this is, I don't remember who said this, but I think this is a good measure for the maturity. Obviously, there are other things that are related to this, like data maturity and whatnot. But yeah, so we used Tekton, which is basically a cloud native CI/CD engine. And we have our code in GitHub at the moment. We do have GitLab and all of the other stuff as well, but we started with GitHub. And what we were trying to achieve is something along these lines. So I tried to represent sort of a workflow from a Git-like perspective, and try to sort of showcase what happens on the infrastructure. Can you see my mouse, by the way? I think you can. I hope so. Yeah, cool. So we have basically a way to sort of version all of the pipelines so that every branch created on GitHub has a reflective sort of naming convention on KubeFlow itself. And that's sort of a smart way for you to be able to keep track of which version of the pipeline you're using. And then we have automation building those sort of images for all the components and whatnot. So you have the capability to trigger orchestrated experiments and do like nice comparisons thereof. And then we have some built-in sort of standard software tests, quality checks and whatnot as part of the sort of CI workflow. And yeah, I decided to sort of showcase a shadow-like deployment, which I think makes total sense in the ML setting, where when, for example, you already have a service that is exposed to customers, you want to be able to run like shadow tests or compare sort of a new model which you want to release, but you want to do that comparison on live data, the exact same data. So it's good that it runs like in parallel over some time, but it's not exposed to the customer until you have validated its behavior. So I can, if you want, potentially dig in a little bit deeper into how this particular template looks like, but that's sort of the starting point for ML teams within Volvo Cars to initiate an ML project. And we, as you can see, we have some linting code formatting and whatnot. But the important aspect is that we enable the automation and sort of onboarding towards the platform, because there's a lot of things that we need to preset, like, for example, setting up a sandbox on LakeFS, which they can use to sort of version their data during their experiments. And you want to have like some pod defaults that are standard for a particular team, make sure that the right accesses and credentials and all of that is sort of taken care of. And we manage the profiles, which is essentially users on KubeFlow. So one of the reasons why we also went with KubeFlow is this multi-tenancy aspect and that type of support. So we can have isolated teams that do not access each other's work. And how we do this, so a profile on KubeFlow is essentially a namespace plus some other things. We have a profiles.yaml file in this project template. So that, I forgot to say this, but the template is a GitHub repository template. So they can just create a new repository based on that template. And then they add a sort of bot user to that, to their project, and that enables all of the CI and stuff. So this profile YAML gives them the opportunity to make sure who has access and who doesn't have access to their project. So a new namespace for that particular project will be created, and then accesses are sort of taken care of by this particular file and some other things. So here's a screenshot from the Tekton dashboard of things that we do in the onboarding procedure, which is triggered when the bot user is added. Any questions so far? No, I guess not. So on top of this, as I mentioned before, the versioning of the pipeline and the sort of building of the images, making sure they are tagged correctly so the right components are being used in the pipeline and whatnot, is what we sort of use this folder for. So all of the automation happens based on this workflows folder, which is in the template. Maybe this would make more sense to show when you go through the whole template, but that will take an hour just doing that. So let's try to go through that quickly. So you can have multiple components, you can have multiple pipelines, and the automation will make sure that they are following a standard naming convention. They are tagged with the commits, basically like so. So all this is a particular pipeline. You have the main branch, and then you have different branches there. So we're opting for like a GitFlow strategy where you would branch out for a new feature and then merge it to the actual pipeline. So here, you know what is going on. And these are sort of the tasks that are running in order to make that happen. So essentially, this is communications with the KubeFlow pipelines APIs, and building and pushing the images to our image registry, which is Harbor, and some other things there. What you may notice here is that we don't automate the sort of running of the pipeline. You can obviously do that, but like, would you want to, on each commit, train a larger model or something like that? That really doesn't make sense. So that's more on demand. You could do automated training, of course, using sort of structures like these, but maybe that is more related to like actual releases. And anyways, we provide a sort of cool option to trigger a pipeline based on a GitHub comment. Idea is to sort of extend this MLOps bot to do other tasks as well, so that they can control, well, in this case, the pipelines API, but you could think of a case where you want to launch a notebook server. Let's say you're reviewing a particular PR, and then there's you want to get that particular, commit loaded with all of the code and all that, and maybe you want to see some diagrams and these things, it would ease the process of reviewing sort of data science and machine learning work, which is a little bit different than reviewing code, because you want to look at, for example, distributions, plots, and whatnot. This is what I said. When it comes to like versioning models and data, there's this CLI tool called ORMB, which enables you to use your image registry as a model registry. So you can have your serialized model in that pattern, have that uploaded to your image registry, just like you would your standard like Docker images with some metadata, and you would have this sort of tagging pattern with shots and whatnot. I thought that was a super interesting and cool idea. Why use another tool when you already have an image registry running? So I thought it was quite smart. And that's what we're basically using. And you could easily reference, a model based on Harbor, and for example, use that in a manifest for an inference service using Kserve, which is neat. And previously we played around with DVC, but that didn't really scale for us. So we're looking into this LakeFS project, which is essentially Git for data. The one thing that we kind of were lacking with LakeFS was a reference on the actual LakeFS commit in the Git repository, something that DVC provided, kind of like a pointer within the repo, so that we know like exactly which version of data is related to this particular commit. And we did an implementation of that in our centralized SDK, which we call MLOps toolkit. And that's sort of where we want to, make sure people load data in the most efficient manner, where we make sure that people don't like reinvent the wheel, use the same patterns, have a lot of sort of boilerplate, which we're taking away from the users. What was the middle icon? Yeah, well, that's just a gradient descent kind of visualization. You're looking for minimum. So it's kind of, it's supposed to showcase a machine learning model. I was answering a question, what was the middle icon between the Harbor and ORMB? So what we're doing is, in terms of like versioning and a reflection, is that we're using ORMB to store, utilize Harbor as an image registry. And we have, within MLOps toolkit, we do have some ORMB stuff as well to just ease stuff up from the users and make sure they are tagged just as they should be and whatnot. And then we use Tekton to basically, I'm saying basically too much. I'm trying to avoid that word. Anyways, that was it. I'll talk a little bit about continuous monitoring. And in the cloud native world, it's quite standard to use Thanos, Prometheus, and Grafana open source tools for like general monitoring. If you want to monitor for ML, I think this use case is fine in certain cases, but you also want to have monitors for things that are happening after you're sending out the predictions. Maybe you don't want to overhead your sort of model, your served model in production with a lot of business logic for creating monitors. So that's something that we are trying to think of. And if you consider the background of an ML practitioner or a data scientist, in order to set up like a custom metric with Prometheus and Grafana, you would need to, define that custom metric, make sure it's scraped by Prometheus, and then you need to have a chart in Grafana. It's a lot of, steps that are awkward for a data scientist or a machine learning practitioner. And I think this is of utmost importance if you want to distribute ownership of your machine learning systems to distributed teams, the ones that are actually developing it. The one who best knows how to set up the actual sort of alerts, thresholds, and what to monitor for a particular model, let's say, is the guys that are developing it. So they need that ownership. So obviously some sort of user interface, some nice abstractions in order to provide that sort of capability to the distributed teams would be great. We have been discussing a bit with a company called Aporia, which I think is doing interesting things. We'll see where that goes. But yeah, so what I'm trying to say is maybe it's not enough for ML, and you definitely need to sort of ease that procedure. That was basically a quick sort of whirlwind tour of what we have been doing. I'm just on the roadmap. We do have some improved monitoring capabilities, as I talked about now. A tighter feature store integration. We're working with fees like, I think it was like version 0.9, something like that, where they did have streaming capabilities built up, and then they did a big revision of the API and general architecture. It's looking very promising now, but we haven't adopted Feast yet. I think it will give us a lot of benefits to what we're working with. Yeah, nice joke there. Roadmap. Yeah. Anyways, one thing that is still a little bit unclear to us is how do we tie Feast together with LakeFS for like data versioning, and then you want to version your features, or you want to make sure that you have a trained model based on certain features. You want to be able to version the exact data that was being used by this particular model, I think. Is that a capability that will be built into Feast, or shall we like combine the two somehow? This is an open question. We want to extend MLOps toolkit in many ways, but one thing that we have been thinking of is being able to generate pipeline and components from the source package. So I didn't really show you the actual structure of the template, but it's opting for basically following good standards for a standard Python project. And what we feel could potentially be possible is based on that sort of package, maybe a main file somewhere where you would be able to decorate in order to set the order of certain functions and components that should run. I think you could compile the actual Argo workflows YAML in a quite neat fashion from that source package, which is something that we will look into more. And being an OEM building cars, we have a fleet of cars. Federated learning approaches are obviously super interesting. You can think of a model running in the car and then updating a global model that is running in the cloud. There are like benefits in terms of like privacy for this, where you just send the weights and you don't need to sort of send the data from the car and these things. And yeah, we're tying this whole system sort of into the sort of R&D department of being able to essentially deploy to car and update services within the car as well, which is an added benefit of working at Volvo Cars if you like that type of tech. Some of the challenges we face are mainly, I think, at the moment related to this. I kind of like this. You can't be an AI expert these days if you don't have some grounding in software engineering. So what we have found is that data scientists are not that great at utilizing Git or collaborating on larger code bases. Same goes for like ML engineers. Obviously, we do have some stronger requirements there, but it's very hard to sort of introduce CI/CD concepts and automate and effectivize the workflow if you don't even know how to utilize Git outside of just storing snapshots in your general sort of code, and being able to don't provide a PR that is just bulk full with a lot of code, and it's very hard for somebody else to review. That is something that we worked quite a lot on, and it's shown great promise. Just data science teams and ML teams are now following a standard review process, and they're actually reviewing each other, which I think is even more important in the ML use case when you're working on complex problems, complex data, a lot of things that could go wrong. Obviously, you need somebody to check what you're doing. Otherwise, you'll break something or you'll end up going in the wrong direction. And coding skills, sort of in general, they are good at algorithms, but general design and being able to use object-oriented programming patterns and these things, it could definitely just be improved. They're not very familiar with these things. So how we see it in terms of expectations, wanted to introduce this concept of a data scientist plus, which should be just general data scientist, by my opinion, but you need to know Git, and you need to be familiar with the concept of CI/CD and potentially working in that sort of procedure. It would be nice to have some container basics, because for when we're working in a cloud native fashion, basically they need to be able to write a proper Docker file. And then we invest heavily on building a culture of testing within the ML community. So that goes from standard software testing and ML testing, because all of these tests will be around the ML system that is being developed. So having familiarity with those things and digging much deeper into the ML testing topic is something that we expect to grow. And general sort of knowledge of certain design patterns. This is just a nice quote. I'll switch gears a little bit, and I know there was a talk about testing recently, so I will try to avoid saying the same things. And I don't think it's the same things anyways, but let's just browse through this quickly because I think it's worth repeating. So we want to treat machine learning like we treat our cars. Volvo is known for safety. We do extensive testing on the safety of our cars. We need to do the same for our machine learning systems. So just going quickly, what are the key differences between software and machine learning? I don't think I need to tell this to this crowd, but let's focus on the testing aspect. In software, you want to sort of ensure that the written logic aligns with the expected behavior. And you do have, everybody knows about regression tests, unit tests, integration tests, blah, blah. But there are some conventions. Let's say you don't merge code unless all tests are passing, always write tests for newly introduced logic. Bug fixes, make sure you have a test for the bug fix and whatnot. But when it comes to sort of, software 2.0, or machine learning and AI, you want to make sure that the learned logic consistently is reflecting the desired behavior. What is standard in the community is to do evaluation. So that entails you evaluate the performance of an established metric on a validation data sets, you do some plots, you go through some operational statistics, and maybe you present some examples where your model most confidently fails. And you compare the performance between models and you make relative judgments. So there are conventions to this, say hyperparams used in training, promote models which offer an improvement over baseline or existing. And just quickly talking about how testing is different from evaluation. So model evaluation covers metrics and plots and summarizes performance on a validation or test data set. And model testing involves explicit checks for your behaviors, that we expect our model to follow. So essentially, you do model testing in order to build up a more of a three-dimensional understanding of how your model actually behaves. And before I go into some revised conventions, I'll just introduce the terminology. So you have a failure mode, essentially a scenario where your model fails, and then there's this concept of behavioral regression, which I think was I read a blog post from Jeremy, which I think most of this is based on that. It was you see a decrease in performance on specific examples in your model. So here are some revised conventions. So these are just exactly the same. So just look at these things. Promote models which offer an improvement over the existing model and passes existing model regression tests. So I don't know if you remember, but when I showed you that sort of GithFlow side, this sort of regression testing methodology was kind of introduced there, where essentially if you would notice that your model in production is not performing well in certain examples, what that would trigger is a new release, or basically you would go in and do some development, try to improve your model. And in addition to that, you would add a regression test to make sure that end models from this particular revision doesn't regress and start performing badly on these examples again. So I think that's a very good concept, which you need to build into your actual workflow when you're iterating on your ML system. And then don't merge unless all tests are passing. And that goes for like the code, the model, and the data. So just some continuation here. So always write tests for newly introduced logic, data, and models. And so those could be like quality tests for data and regression tests for models, or whatever it might be. Always those are the same. When a failure mode in your ML system is identified, be sure to write a behavioral regression. So I kind of told this. What we want to do is introduce this concept of a red team for machine learning. So that goes into sort of, to some extent, also external auditing, but also a cross-functional team responsible for maintaining the operations of this machine learning system and making sure that it's behaving as you want. And they would also be the ones stress testing the system before the model is released to customers. So what they should do is try to break the system in all way, shape, or form. And they would monitor the machine learning system and identify failure modes and track and prevent behavioral regressions. Sorry, I saw a question here, maybe.
Yeah, there's a question coming through. It's asking, do you have a framework for your tests or templates or something?
No, but it's something that we have been thinking about. We do have some students coming in. What we thought of was you could potentially have an SDK that would ease the procedure of testing machine learning models. And from my sort of perspective, being able to effectively write good machine learning tests boils down to being able to slice and dice your data in smart ways for you to find like good examples or particular examples that you could design tests for. So I know there are certain frameworks available for those things, but we have been thinking about having those aspects as a submodule of MLOps toolkits at some point. But at the moment, that is not like fully developed. so just saying this, now I talked a lot about tools and stuff like that, but from my perspective, I think it's more of an engineering practice. And one of the big things is mainly cultural and transforming these teams so that everybody involved in the process of developing a machine learning system have certain guidances in mind. And I think these two resources are good to have, and more or less everybody involved should be accustomed to these rules and apply them during the sort of life cycle of that particular project. Here is a sort of snapshot of Martin's rules for ML. It's written in a way that sort of a layman can understand what it's about, which I think is very wise. And I saw this talk yesterday about ML testing, this Svet Penkov. I just have to say this. I think his way of discussing the operational domain and how he was perceiving sort of machine learning testing led me to think that it would be nice to introduce this additional fourth rule before jumping into ML and developing the system, is to clearly define an operational domain for your system, which makes it easy to get requirements and have that as a framework for further testing.
Just a quick one in there. Sorry to interrupt you, but Tatiana was asking, what was the timeline for Volvo MLOps system development and components, introduction, adoption, that kind of stuff?
I'll try to interpret this correctly. So if I haven't, then in terms of timeline for succeeding with ML or adoption of these things, the team that I'm part of or driving, ML engineering and operation, is part of a sort of central unit that works horizontally across the company. This sort of unit organization, or data and analytics, was recently formed in January. So we got this upon ourselves in January. And the goal is to have a sort of clear value ROI from ML and make sure that we have maintainable and robust systems within 2 years, basically. So if that is a good timeline, is that what you're asking about? Yeah. We can discuss the history of how this came to be, but yeah. I think we're, the slides are basically done. I just want to put this out there. If you're interested in joining, we're hiring. And yeah, some references and some nice links. And I think we don't need to watch the video. We can focus on other stuff. But
that is a hilarious video.
Ariel's video. It's a fun video.
Yeah, it needs to happen. That video is great for whoever has not seen it.
Yeah, just see it. It's funny.
Yeah. And so I've got a question to, we'll send a link to the video, and we'll also send a link to the slides. That'll probably go in the email newsletter coming out when I do a little write-up on the actual, the talk, or myself or Carlos, who is helping with that. And so I've got a question while people are thinking of other questions. There was this challenges that you were talking about, and you're looking at some of these like main challenges, but what are some things that kind of snuck up on you? Like, I imagined you saw, or you budgeted and expected things to happen. What were some things that came out of nowhere and hit you kind of hard?
That's a hard sort of question to ask. Well, one challenge that was definitely something that we didn't expect was we went into KubeFlow quite early on, so 0.7. And for us, the being able to sort of install and configure and get all of those services running correctly was a huge hassle back then. Right now, it's been unified and it's very easy, but we didn't have that sort of opportunity back then. So we needed to sort of set up already at 0.7. We utilize GitOps and Argo CD to sort of sync our manifest. So we needed to do like a lot of rewrite, and then we have some standards like sort of our Istio version in the rest of the clusters were not in line with, the one that KubeFlow was using. So we needed to make it work with the same Istio version as the rest of the organization was using. And that was a hassle before, and I wasn't back then. I wasn't like fully, I didn't know Kubernetes that well. So I have the complexity of installing KubeFlow to thank for my knowledge in Kubernetes.
YAML, you learned YAML through KubeFlow.
Well, basically, you went into details. Like I know Istio way better than I should. Let's put it like that. But yeah.
Well, along those lines, that's something that I tend to ask people quite a bit is, and it sounds just mayhem when you showed us that first slide and you have so much going on there. How and who is responsible for making sure that you stay up to date with patches, security flaws, dependencies? There's so many things that you need to keep in mind for all of these moving parts. Like, is that your job?
Well, partly it depends. So I think, sorry, I'm trying to get this slide. A lot of what's on this slide, everything is not implemented as of yet. Like Amundsen is not running now, but to answer your question, we do have a central DevOps team that essentially, they are responsible for running, let's say, the vanilla cloud native stack. They're running Elk system. They are making sure that our Argo CD is running and fully functional so that we can deploy to all of the clusters. They are making sure that the Istio and the Kubernetes version, all of that stays up to date. And in addition to, on top of that, we add sort of, let's say, the ML layer. And that is something that we are fully responsible for. And then when it comes to sort of the ML systems that are actually running on the platform, we want to have distributed ownership, but it's kind of a hub and spoke situation.
Yeah, I feel you. Somebody's asking about the slides. Yes, we're going to share those slides. And do you deploy KubeFlow on Google Cloud or a less stable or default option?
Well, we're at the moment, the ML clusters are running on AWS, but we are using kops to build that Kubernetes cluster. So we want to stay cloud agnostic in every way, shape, or form. That's a strategic decision. So we're not using that many of the managed services. That's also one of the benefits of KubeFlow, for example. We do have Azure, we have GCP, we have AWS, and we want to data is distributed across those things. So we would need something that works across all. And there's this concept of price and cost, and you should be able to move from one to the other in a seamless fashion. So it gives us more control over the clusters.
Yeah, and you don't have to worry about vendor lock-in. It's one of those fears that people are always mentioning. I have one that maybe maybe you can answer this, maybe you can, but it's not necessarily along MLOps. It kind of is. There's a lot of hype around Tesla and the self-driving cars. Are you guys doing anything with that?
Nothing with Tesla. But,
no, sorry, with self-driving cars. Obviously not with Tesla.
I was joking. So Volvo Cars, obviously, we're into self-driving capabilities. There's a separate company called Sensiact, which is owned by Volvo. And they are working mainly with the AD function. So they're developing an AD function, which ideally would work for Volvo and potential other OEMs as well. And they are heavily invested in those. We do have touch points, obviously. And yeah, that's how it looks like for Volvo. And then Volvo as a company do some validations of the AD function, because this AD function needs to be sort of put in the cars.
Yeah, that makes total sense. That's super interesting. So then that is like a separate project, a whole nother company that is really knee deep in it. And you have a few different touch points with them to just make sure that what they're doing jives with what you've got going on. And
yeah,
that seems about right.
And some of these choices made for like what you can do, like training these models that are actually, you know, the ones that would be running on the same sort of, let's say, the car platform or the VCU. They're quite one-to-one.
Awesome. Another question coming through: are the data ops, model ops, and DevOps different teams? I don't even know.
Yeah,
yeah. How do you organize this?
I wish we would have a data ops team. Well, it's not really called data ops team at Volvo Cars, but we do have some a resemblance of that. And if a model ops means MLOps, in this case, we don't have a separate model ops team. We do have an MLOps team. So we are centrally trying to work that out, and then we own those domains in addition to sort of the engineering aspects of like optimizing machine learning models and whatnot. And the DevOps team is a sort of separate team as well. So that's kind of how it works. And when it comes to having on-premise infrastructure for ML, yes, we do have like private clouds and these things as well. So one of the benefits of being cloud agnostic is for us to be able to sort of map this over and just run it on other clusters as well.
Yeah.
Right now, our efforts have been focused on the AWS clusters, but that's on the timeline. And we do have some separate tooling as well. They are heavily optimized towards certain use cases.
Yeah, makes sense. So there's one other question coming through saying, oh, I cut in and out a bit. Did you talk about what kind of data is flowing in? Is it streaming? I'm guessing it's sensor data from the plants where you're making the cars, or maybe it's much bigger.
Yeah, so I think it kind of makes sense. I think this picture, we didn't talk about this that much, but having sort of a central sort of Kafka event-based system when it comes to connected car cloud and the sort of communication with car and cloud, and this is highly event-based. And you do have event-based things in manufacturing as well. So we have a lot of different data, a lot of legacy or more tabular things from like finance and logistics and whatnot. So, but we're opting for having an event-based infrastructure where we can, work with data in real time and figure out a good consumption pattern and producing pattern for data. But yeah, a lot of it is event-based.
So this is super interesting. Then, like you said, there's so many different use cases that you're tackling. How, when you're making these design decisions, are you trying to create a blanket platform that is the centralized platform? Or are you thinking about certain use cases more than others?
Well, we try to like generalize and obviously try to hit what is the hit two birds with one stone, sort of say. But in certain cases that maybe doesn't make sense. So let's, in manufacturing, for example, with all the monitoring and that type of data that goes on there, like I do see a potential need for sort of a sensor fusion based platform to sort of aid that sort of capability to work with all of the sensors and then have that sort of jack in with what we're doing. So I see that as extensions, but they are, let's say maybe more specialized. And the same thing goes like if you think about like the car deployment and you need to have test rigs to figure out that the models are running as they should on the actual hardware and these things, there are maybe more specialized things will come up in that procedure.
Awesome.
Did I answer your question?
Yeah, super interesting, because that's a problem that I hear about a lot. And it is something that, like, if you have different use cases, how do you decide which ones to optimize for? Are you trying to make a centralized? This is something that also is an interesting one to tackle. Is it a centralized platform, or do you go with decentralized with the different teams and how they're going about it? These are really interesting questions for me to explore, and how you want to create a little bit of liberty and autonomy within the company so that teams can do their own thing if they feel like they can do it better. But then again, you don't want to just have this sprawl of everyone doing anything that they want. And so there's a very fine line that you get to, right?
Sure. And obviously, you're mitigating some technical depth if you're following like standard procedures and patterns. You don't want like too much reinvention of the wheel, but you need to stay dynamic and up to date and listen to the actual users and their use cases to adapt towards that. And I think that goes into like building an internal like community and have like a strong community of collaboration. Like, for example, like my team is not like particularly large, and it's like impossible to like solve the things that we want to solve for within that like time frame unless we get like activity from outsiders. So we're trying to build kind of an open source mindset, but within the company where we get like contributions to a large extent.
I see. And once again, we will remind everyone that his team is hiring. So in case you want to go work with Leonard, how big is your team?
Right now, we're 6 people, and the goal is to be double that size. So we have some open roles. This is crazy. How can I like flip? I should be able to flip to the actual slide number.
The slide.
I use Mark. I don't know if you're aware, but let's just show this so you can
if you want to reach out.
Scan this QR code.
Well, I've got one last question for you before we end it, unless anyone else has another question that they want to sneak in at the very end. And this is one that you mentioned, and I like this term, data scientist plus. How hard is it for you to convince the data scientists they need to be doing what you put on that slide?
Well, the spectrum is quite large, but I think many has recognized the benefit from it and do understand. So I think mostly it's very positive and people are open to learn new things. And many of these are not like rocket science, incorporating Git and learning like Git basics in order to like get up to speed. If you're a data scientist, you're coming from probably working with more complex problems than Git. So just spending a couple of days learning that and the sort of benefit of it. So what you need to sort of, how you would tackle such a thing is you talk about the benefits to them and their team. Like, for example, being able to review and having more control over your code and collaborate with your colleagues in a smarter way is most of the people thinks this make total sense. And I think, yes. And then there are obviously some that come more from a research background, and they're like, you hear things like, why should I know how to read data in parallel in a more very efficient manner from an object store? It's like, that is obvious to me that you should know how to read data as a data scientist, but the spectrum is large and there's like unclear expectations. But generally, I think most data scientists are strong on domain, maths and statistics, and the software engineering, these should be equal. It's a cross-functional role, but in reality, you don't, you're lacking somewhere usually. So if you come from software, you're maybe not that great at stats and maths, and you need to sort of make yourself a little bit more full stack. But we don't want to force data scientists to like write YAML and become DevOps engineers. So you use kubectl, but being able to understand certain patterns to just generate something that is maintainable. So we can have this handover of like, here's the Jupyter notebook, and then an ML engineer needs to do something with that sort of piece of garbage that isn't versioned. They have no control over it, essentially. So, and I think it's going well. It's going well, and we have a lot of guides. We have a lot of like teaching material in this sort of central knowledge platform to sort of set up clear expectations.
Yeah. So last thing I'll say, and then we're going to finish it off here. This has been awesome. Thank you so much for the presentation. It looks like people are putting in to the chat that they also loved it. I think that I might try and harass you to create a blog post about this idea of doing open source stuff inside the company, like creating an open source mindset inside the company. There may be a blog post there. We'll see if I can get you to write it while your free time. And this is awesome, man. This is so cool. I really appreciate you coming on here. Like I said, it's been great. You've enlightened us all with how you're doing MLOps at Volvo, and keep up the great work. Thank you everybody for joining us. If you're watching this in the future on YouTube, give us a like and a subscribe or leave a comment. All that is great for the engagement, and it can let more people see this amazing talk. That's all we've got for today. See you, Leonard.
Thank you.
See you, everyone.
Honored to be here. Have a good one. Just reach out if you have questions.
There you go. And Leonard's in Slack, so hit him up on the MLOps community Slack if you have any more questions or you want to get hired. Come to Sweden. It's in the summer though.
Yeah.
Go to or bring your vitamin D with you if you're going to work with Leonard.
Winter is not that bad. It's beautiful winter time. I mean,
there you go.
At least if you're very up north.
Yeah.
Yeah.
Northern Lights and snow. There's all kinds of cool stuff. You can go skiing, kind of.
Yeah.
I guess you can go to Norway. So
yeah.
Awesome, man.
Yeah, cool. Nice talking to you, and have a good one.
Take care.
Bye.